Hello everyone, this video is all about execution of the list implementation using arrays. Now I will show you the main function I have defined 10 operations. Display is one among them. Okay, so I have taken switch case where each case is at each case I have called a function. So these are the functions I have defined: insert end, insert begin, insert after, insert before, delete first element, deleting the last element, deleting a specific element, and modifying an element, and searching for an element. At the same time, display function. Okay, here A is an array and n is its size, right? And whenever OP value is 1, it call insert end. Whenever it is 2, it will call insert begin, something like that. I think you all well aware of switch case functioning, right? And I used to keep all this part in do while loop. Okay, so here I am going to display the main menu first. So where the same order in the cases, whatever the order I have taken, the same order here I have displayed the functions, so that user will choose the right option, and using scanf statement I will take input for that right option, and this switch case will get executed. Well, I am using a do while loop here. So here I am using a condition that when ch is equals to y means yes. Okay, when ch is equals to y, that might be a small y or capital Y, the condition set to be true, and all this process will be repeated from here. It displays menu again, and it will ask us to opt an option, and we will choose a function, and that function will be executed. Okay, right, here whenever I choose 10, program will be terminated unconditionally. Okay, if I don't want to continue and I don't want to run any of these functions, then I will choose the case 10, so that we will exit from the loop. Okay, well, here before verifying the ch value, I am taking input from user using scanf statement. So if user enters y, okay, then condition will be true. If he enters n, then condition will be false. Right, now we will discuss each function among these 10 one by one. First of all, let me show you displaying the list of elements. Okay, assume that I already have a list. Okay, and in that display function I have passed array name as a parameter. So here this A is going to take the reference of that array, and here size is the size of the array. Okay, so n is passed, so n value will be assigned to size. Now if size, before displaying the elements, I will verify whether at least one value is there in the array or not. If size is greater than 0, that means there is a list available. If size is not greater than 0, means there are no elements in the list. So if size is not greater than 0, that means else I am going to display list is empty. Okay, fine, list size is greater than 0, that means there are some elements in the list. Then I will use a for loop. For I is equal to 0, I less than size, I plus plus, I will display each element, %d space. Okay, A of I. Well, here we should remember one thing, that the indexes of an array varies from 0 to size minus 1. Suppose if you have 5 elements in a list or array, okay, then the first element's index will be 0, then second element's index will be 1, and so on. The nth element's index will be n minus 1. That is why here we have taken this condition, I less than size. You can also write it like this, I less than or equals to size minus 1. Both are same, I less than size or I less than or equals to size minus 1. Okay, you can write anything. Now up to size minus 1, it will display each element in each iteration. Okay, so that is the display function. Now I will explain you the search function. Okay, so I want to search, so I am passing array name as a parameter and array size as a parameter. Okay, then here A receives the array values and size receives the size, n. In the calling function we used to pass n, right? Now here see this, I want to search for a key element, that is why I have declared it here, and I read a value and I took input using scanf statement. Okay, so I have entered a key value. After entering key value from the output screen, console, then you have to search whether key exists in the given list or not, I mean given array or not. So from I is equal to 0 to I mean size minus 1 to size minus 1, I repeatedly verify whether key is equal to a of I or not. So if I is equal to 0, I mean for I is equal to 0, a of 0 will be compared with key. Okay, if not matching, I will be incremented, and a of I, that will be a of 1, will be compared with key. If that is also not matching, then I will again be incremented, and a of 2 will be verified with key. So whenever key is matching with the one element of a, okay, then we will set flag to 0, because initially I have taken flag as 0. So we will set flag to 1. We will set flag to 1, and we will write a break statement to exit from the loop. Whenever break is encountered, control will automatically come to the end of the loop. Okay, so here whenever key is found at some index of I, let us say if the list is consisting of 10, 20, 30, 40, 50, okay, 10, 20, 30, 40, 50, and if you are searching for a key value 30, then 30 will be verified with 10, 20 and 30. Here 30 is matching with 30, so the index corresponding to 30 is 2, because index starts from 0, 0, 1, 2, so that index is I now. So a of 2 is matched, right? Then we are going to return that index. If item is found in the list, then the corresponding index will be written. If item is not matching with the key at any, I mean for all the values, means the item not found in the list. When item not found in the list, you just return -1. If item found in the list, you just return I. Okay, and wherever you are receiving these values I or -1, in that function you have to assume that whenever the return value is -1, the searching element is not found in the list. Okay, whenever you get a valid I value, a positive I value, that means that is the index of the value you are searching for in the list. Okay, so this is search operation. You please understand this search operation, because we used to call it many times in other functions. Okay, right. Now let us see insert an element at end of the list. That means let us say you are having 5 elements in a list, 10, 20, 30, 40, 50. Okay, among them you want to search for, insert one more new element to that. Okay, you want to insert one more new element to that at end position. I already told you, whenever values are there in an array, values will be corresponding to the index values, index starting from 0. So first value's index is 0, second is 1, third is 2, fourth is 3, fifth is 4. Now I have already 5 values are there. Okay, so what is n here? N is 5. So the last index is n-1, that is 4. Now you want to insert a new value. So here n means the size. Okay, so the new value has to be stored in array associated with the index 5. Okay, when 4 elements are there, means when size of the array is given, size -1 is the index of the last element, so you have to insert a new element with index size. Okay, that is why we are reading an input value for insertion, and this value will be inserted at a of size. That is why I am assigning value to a of size. Now if 5 elements are already there, then the index of the last element is 4, so in a of 5 is equal to value will be executed. Okay, now a new value is assigned. So after assigning the new value, what will we do? We will return the size. The size of the list is already incremented by adding a new value, so the size of the list will be size +1 now. So you have to return the size. Okay, I will show you in the program function call in main function. See here, I have called the insert 10 and return value is captured by n. Okay, here I am passing 5 as parameter. After inserting a element, you are returning 6, so n will be incremented. Now size of the list is incremented. Okay, like that we are making function calls. Now we will see the insert begin. Okay, means I want to insert it at beginning position. It is at end position, so very easy. But beginning position means we have to follow some procedure. So here I have written the code for insert begin. See this, insert begin. Right? So what we are doing is we will take the input value and now this value has to be inserted at the beginning position like this. Suppose you have 5 values 10, 20, 30, 40, 50, and now you want to insert a new value. Where do you insert? You will insert in the beginning. So whenever you insert a new value in the beginning, all the remaining values were shifted to the right. Okay, so before inserting a new element, you have to create some space for the new element by shifting already existing values to the right ones. Okay, from where to where? See here, let us say this is 0 index and this is 1 index. This, I mean 10 is at 0 index, 20 is at 1 index, 30 is at 2 index, 3 index, 4 index. Now you want to insert a new element at 0 index. Then what will you do? This 5 index will be shifted to 6 index, and this 3 index will be shifted to 4 index. This 2 index will be shifted to 3 index, and this 1 index will be shifted to 2. 0 index will be shifted to 1. Now there is a space for this. There, I mean at 0 position, a of 0, we will put the value. Okay, so after doing these 5 shift operations, you are doing insertion. Okay, so how could we do that? You just see this for loop. Here what we have done, if you see this closely, you can understand what we have done. See, I am starting from size -1, and here size is 5. So size -1 means 4, that is index associated with the last element. Okay, and when I is greater than or equals to 0, okay, I am doing this. A of I plus 1 is equal to A of I. That means A of I plus 1 will be the index 5. So this will be shifted to the next index. Okay, then what will I do? I will shift this to the, that means I is decremented, so I will be 3. This will be shifted to the next index. Okay, then this will be shifted to the next index. Okay, then this will be shifted to the next index, and this will be shifted to the next index. Now what happened? You were having space for new value when I is equal to 0. When I is equal to 0, you have assigned this, and I value is decremented. Now I value is -1. Okay, because 0 minus minus is -1, so I value is -1. This condition got failed. When this condition got failed, you are coming out of the loop. After coming out of the loop, what you are doing? You are assigning new value at A of 0. So this is inserting at beginning. After inserting a new element, the size is incremented, so you have to return size +1. So this is inserting at begin. Now let us do this function, inserting an element after a specific value. Suppose let us say, let me delete this example here. This is not a part of code, so we should not write here. Now let us see, I assume that I have these values 10, 20, 30, 40 and 50. I want to insert a new value after 30. Okay, whenever I want to insert a new value after 30, please observe this. Here I am inserting 60 by shifting 40 and 50 to the right. By shifting 40 and 50 to the right. So this can be done like this. See, so first of all we should know the index of the value after which you want to insert. So the index of this value is 2, because this is 0, 1 and 2. So after knowing this, from 3 to n-1 you have to shift to the right. Okay, 50 has to be shifted to the right, 40 has to be shifted to the right. Then you will be having space after 30. There you have to insert a new element. Okay, so for that you just call a search function, search of a comma size. In search function itself we will read the element after which we want to insert a new value. Okay, because here I read the new value, here I read the new value. Now I want to search for an element, so here just I am writing a printf statement after which value we want to insert, but the value will be, I mean the input will be taken from search function itself. See here in search function I am asking for the value, so key value is being entered in search function itself, so no worries. Right, now this search function returning some index, okay, of that value. Suppose if 30 need to be searched in the list, then the corresponding index 2 will be returned by search function. We have already verified that in search function, right? We saw that. So search function returns 2. Now I value is 2. Let us say for this example I value is 2. When I is 2, okay, so here I am verifying that whether the 30 exists in the list or not. So in that search function we are returning -1 when the value does not exist in the list, but 30 is there in the list, so I not equals to -1. This condition will be true, so we'll enter into the if. Right, now what is I value? I value is 2. So here I will start from what index I have to shift to the right? From I plus 1 index I have to shift to the right. That is why I used to write j is equal to size minus 1 to I plus 1. J is equal to size minus 1 to I plus 1. I have to shift elements to the right. How? A of j plus 1 is equal to A of j. Then A of j value will be assigned to A of j plus 1. The before value will be assigned to neighbor 1, and so on like that till you reach I plus 1 position. Okay, all the values will be shifted to the right ones. After then you will be having space for the new element here. There, I mean at I plus 1 location, A of I plus 1, you are going to insert the new value. So by writing this value, A of I plus 1 is equal to value. Okay, so now a new value is inserted, so size of the list is incremented, so you are returning size plus 1. This is inserting after some specific value. Now let us see the insertion of an element, a new element before some value, same as before some value. You just understand this. Suppose let us say I want to insert, this is the list actually 10, 20, 30, 40, 50 existing. I want to insert a new value 60 before 30. Okay, that means what? I have to shift from 30 to the right and insert value at ith position, that is 30th position, 30 original position. Okay, so what is the corresponding index of 30 before inserting an element? That is 0, 1, 2. 2 is the index of 30. Okay, so at 2 position I have to insert the new element. Before inserting the new element, I have to shift all the elements from n minus 1, that is size minus 1 to I to the right. Then I will be having space for a new value at ith position. Then I will insert new value. Okay, so how could I get this ith position? By search function, by calling the search function. So here I am calling the search function. Okay, so this search function will return I value. This I value is the index of the value before which I want to insert a new value, right? So here I index is 2 in our example. Now let us say j is equal to size minus 1, means size minus 1 to I, rather I plus 1 we are taking I. This is only the difference. Okay, so before function, after function has only small difference, that in the in the after function I have taken I plus 1 here and I plus 1 here. In the before function I have to take I here and I here. This is only the difference, nothing more than this. Okay, and if value is successfully inserted in ith position after shifting all values from I to n minus 1 to the right. Okay, now you have to return the size, incremented size. Okay, because a new value is inserted, so size of the list is incremented. Previously 5, now it is 6, so that incremented size plus 1 will be returned. Okay, and you may get a doubt that why I am always starting from size minus 1 and going to I by decrementing j value. Why don't I come from I to j minus 1? Why shouldn't I go from I to size minus 1? We cannot go like that, because suppose let us say if this is the list 10, 20, 30, 40, 50 is the list. Okay, what is the ith index? 30. If I take I here, I mean if I start from I have to assign A of I to A of I plus 1. Okay, what will happen then? This 30 will be placed in the this 30 will be placed in the next position. Then you lost the 40. After incrementing the I, again the same 30 will be placed in the next position. Then you will lose 50 also. You can see only 30 is in all the remaining values. So that is why we should not start from I and go to size minus 1. We have to come from back side. First of all, we have to safeguard the last element by shifting it right. Then we have to safeguard the next last by shifting that to right, and so on. We have to do it till the ith index. Okay, so this is inserting before. Now we will see deleting a specific element. Okay, before seeing deleting a specific element, let me show you deleting a last element. This would be very easy one. Deleting a last element, what does it mean? Let us say I have these values 10, 20, 30, 40, 50 in my list. If I want to display them, how could I display? I will pass the size is 5, so 5 will be passed. Then we will display the elements corresponding to indexes 0 to 5 minus 1, that is 0 to 4. Okay, if this size value is reduced, that means if it is reduced to 4, okay, then the indexes corresponding to 0, 1, 2 and 4 minus 1, that is 3. These values will be accessed from the list, and after them we should not consider, because up to size only the valid values in the array. Other than, beyond the size we should not consider as valid values in the list. So logically that is removed. So same thing we are doing here, rather doing any external process and just returning size minus 1. By returning the size minus 1, I can delete the last element. Now size became 4. Okay. Similarly, suppose if there is no element in this list, let us say 0 elements are there in this list, and you are still attempting to delete the element. Okay, then is there any possibility of deleting an element? No. Then we have to should display some error message that there is an underflow. Means you are attempting for delete operation on an empty list. You are attempting for delete operation on an empty list. That is called underflow. Okay, right. This is deleting the last element. Now let us delete the first element. Okay, first element means the element associated with 0 index. Okay, let us say I have these values in the list 10, 20, 30, 40 and 50. Index of 10 is 0, so I have to delete this 10. Okay, then what could I do? I have to shift this 20, that is indexed 1 to index 0, index 2 to index 1, index 3 to index 2, index 4 to index 3. Okay, and let us reduce the size minus 1. Then we will access these first 4 values. Okay, so 10 is logically deleted. By overwriting the 10 with the right side values, you can delete the value. Okay, so you are doing left shift operation here, rather right shift. Okay, right. So what we are doing is we are shifting all the elements to the left ones, so that the first element will be deleted. So this is one of the ways to delete the first element. Now let us see how I have done this in the program. I is equal to 0 to I less than size minus 1 I plus plus. I am assigning a of I plus 1 to a of I. So when I is equal to 0, a of 0 is equal to a of 1. That means the first one indexed value is going to occupy the 0 index. Then 2 indexed value will occupy the 1 index. Like that up to size minus 1. Okay, so this is what up to size minus 1, but here we have taken less than size minus 1 because when we consider I plus 1, then size minus 1 plus 1, that is size only. Okay, right, like that we are going to do. Right, now this is deleting the first element. Now deleting a specific element. Deleting specific element, deleting first element are same, but here in deleting first element we are shifting all elements from 0 index to the left. Okay, and here we have to do the same, but from I index. Okay, because we want to delete a specific element. Whenever we want to delete a specific element, see here I will call a search function, so that such function will search for that specific element. Let us say I want to delete 30 in this list. This list consists of 5 values, so I want to delete 30. So index corresponding to 30 is 2, so 2 will be assigned to I after calling the search function. Now this 2 element associated with 2 has to be deleted. Then what will I do? This 40 has to be shifted to, the 3 index will be shifted to 2 index, 4 index will be shifted to 3 index, and size will be decremented, so that this will be the list. Now 30 is deleted logically. Okay, so that is what I am doing here. I am starting from I, j is equal to I, and till size, till I reach the size, that is size minus 1. In fact, it is less than, not equals to, so size minus 1. Then all the elements will be shifted to the left. So for I, a of I is equal to a of I plus 1. Means a of let us say in this case a of 2 is equal to a of 2 plus 1, that is a of 3. Okay, like that we used to shift the elements. This is deleting specific element. Okay, now see this if else statement. So here I am taking this every time because this is the search function I have called. In that search function I have mentioned that if element found, corresponding index will be returned. If element not found, minus will be returned. So I have to write any logic only when the I value is not matched with -1, not equals to -1. If I is equals to -1, that means element not there in the list. Then I am not supposed to do any delete operation. So I will display entered element is not found in the list. Okay. Then size of the array will not be changed, so I will return actual size only, same size what we have received previously. Okay, will be returned back. If deletion operation is successful, then we will return size -1. We will return size -1. So this is the program for this is the function for deletion. Apart from this, we will also having modify function. Okay, same as before, nothing is different. Whenever you want to modify some value, okay, so you just call search function. Okay, by that you will find the index of the key value which you want to modify. Like this, suppose let us say you have 5 values in the list and you want to replace 40 with 60. You want to replace 40 with 60. Okay, this is what we call modification, right? Now how could I know the corresponding index of 40? By this search function. So after running this search function, I will get the index value into I. Okay, so whenever the search is successful, I will input the new value to replace the previous value, and that value will be assigned to A of I. Simple assignment is enough for modification because you have to replace the previous value with the new value. So A of I is equal to value. What we have done is only we have performed a search operation to get the index of the value you are searching for. That's it. Then with that index value we will store the value. That's it. So this is a modify function. So these all are the most possible traditional functions that we apply on list implementation using arrays. Okay, we will also see another video which will focus on list of names. We will take list of names and we will try to practice various operations on that. Okay, later we will also see the list of records. Okay, and we will perform various operations on records. So by that that is more than enough to understand the list implementation using arrays. Thanks for listening.